Well, hi, thanks for joining me here in my shop. It's day 2 on the Messenger CB radio here. Since the video I did yesterday where I just kind of took a look at this to judge its general condition, which is really good considering how old this thing is, I did turn it on. It did seem to be working, and the impression I got from all that is, including the fact that there's very few parts in this that would typically be unreliable at this point. Very few, five parts maybe. This is really good. It's not full of wax capacitors, that's what I'm trying to say. It is full of capacitors, but not wax ones. So since yesterday's video, I managed to acquire the entire service manual for this radio, and I've also, look at this, I've got a real CB antenna here. I had to come in here late last night, fix this guy up. I've been dragging this antenna around with me. There's the end of it. Dragging this antenna around with me for years and years, and it's been broken. The lead wire was just cut clear here. So last night I came in and fixed it up, so now I have a real CB antenna. I can hook up to this. That's for when I eventually get around to transmitting with it, working on the transmitter. I also have installed in my shop a CB radio monitor. So this is a CB radio here. Nothing to hear. It's hooked up to its own antenna. Here's the antenna lead. It's just sitting in my laundry room out of the shop here. It's not this antenna here. So this one I put a PL259 on it, so it'll go right onto the radio. I also have another one of these sitting in the other side of my house in my office. My evening hangout, and so we can do transmitting, receiving back and forth in both directions. But the transmitter side of this is going to come later. The first thing I should focus on is the receiver side of this radio. So we're going to take a peek at the service manual here. I'm not going to drag you all the way through. I just want to show a couple of diagrams here. Okay, so here we are on, we're somewhere in the middle of the manual. Page 5 of 15, but this is only half the manual. It's actually about 40 pages in fact. And so this diagram is a block diagram of how the radio works. What it tells me, and this might not be absolutely true, but what it's suggesting to me quite strongly is there are really two quite separate radios in here, not sharing very much. So you have the receiver part here, and then you have the transmitter part here. There's no interconnection shown in this block diagram anyway. Some of these radios can share things like IFs and things like that. So this one appears to be quite separate. Great. Just lots of information. Theory of operation. That's why I'm really encouraged to work on this guy. Now we got to stop at this diagram here. Let me just flip it around. Receiver alignment and test equipment connections. So what they're showing here is the way to hook up your shop equipment, and it's quite straightforward. Here they got the signal generator. I've got one that will do this, 455 to 50. Frequency counter hooked up to it. I've got that arrangement. And then we've got a lead here. It's going to go into the different IFs, I guess, as you progress through the alignment. You want a DC VTBM hooked up to the diode load part of the radio. This is where the signal has been rectified in the detector, and you pick up. I think if this is not exactly the ABC voltage, it's the same kind of thing. The DC here, and then you have an AC output meter connected to the speaker here. That's what they're showing up here. That's the equipment arrangement that I've got it set up. It's typical. This is just the way you do almost any radio. Now, is there anything else? Quick look at this. So this is for checking out the transmitter, which is not a concern yet. They give lots of different values here that you can check on with the set operating, with the set not operating. Lots of voltages to check. So this is a really great manual here. Look at this one. You put in these different RF voltages into the back of the radio, and then you should read this output, and you should read this ABC voltage. That's a pretty good check of quite a few things in the radio all at once. Got a little diagram here for a special connector and whatnot. This is a really thorough manual. So I'm going to go back here. So that's the main thing. That's what I wanted to show you. So the idea is we can kind of concentrate on the radio alone. So I'm going to study the manual a little more. I'm going to figure out where the signal generator is supposed to be connected in here, which tube is which, and what terminals would be connection points, and get ready to, I guess, feed a signal into the IF and see what comes out of the speaker. I guess that's where we're heading here. Okay, so the first thing we're going to do right out of the manual is burnish the contacts on this relay. Again, I think the relay is only important when you go to transmit, but it's the first thing it says is anytime you open the cabinet, burnish the contacts. So that's what we're going to do. It recommends just a piece of paper for the burnishing tool. So I'm just going to cut a strip here. You never use anything abrasive whatsoever to do this kind of thing. Got that? But never. I've done it. It's not smart. So try to get that between the contacts very carefully. Just maybe they're closed right now. Let me pop them open. Maybe my paper strip's a little wide here. It doesn't want to go. There it goes. Get in there. Okay. Gotta wonder how well this is working here. Okay, let's push it back. I see a little bit of color coming off. Put a little pressure on it. Pull it out. Not much of anything. And it could be contacts underneath there too. Well, it does not move very far. That's really the width of a piece of paper. Let's see. What can we see in the camera views there? I'm trying to see if there's contacts underneath. Did I bend that upwards? I didn't bend that piece upwards, did I? This piece here? No, it's very stiff. I don't see any contact underneath. So I think we're okay. Gee, it just has that terrible look of being bent up, doesn't it? But I don't think there's any way. I've moved. Okay. Well, so much for that procedure. You've done it though. The boss asked me, Jim, did you burnish the contacts on the relay? Yep. I did it. Okay, next thing is to start sorting out the connections of the equipment. Let me work on that off camera, I think. Okay, I think we're all set up here for the first test. Let me just go over what I've got going here. So, signal generator, frequency counter. Look, it's at 27.7 right now. Got this connected to the speaker so we can measure the output voltage reaching the speaker. The output from the signal generator goes through first this box, which introduces a capacitor just to make me feel a little better. Changes the impedance a little bit so the signal generator sees 50 ohms this way. Looking back this way, it's no longer 50 ohms now, and so this might be a bit of a problem. Looking back this way, it's frequency dependent, maybe 200 ohms. So the radio through is seeing 200 ohms here. It's probably not quite right. So I'm not going to worry about that right at the moment. So I have a switch here, so I can switch between, so I can switch the input to the radio from the signal generator to the antenna. Yeah, the antenna is just sitting here in my shop, but nevertheless I can do that. I've also thrown in, just for fun, and not important at this point, is this field strength meter for CB radios that I have sitting here. And I've just put it in. Eventually this will be of some value down the road. So I thought I'd put it in now. I also have, by the way, a resistive dummy load here, 50 ohm dummy load I can put on the back of this radio anytime I want, because this is requested in the instructions. What am I missing? Not missing anything here. So the objective now is simply to check the receiver by feeding in a known signal strength and then seeing what kind of voltage is supplied to the speaker. So that's why this voltmeter is on here. It's on the 3-volt scale. If everything is working properly, and there's big question marks around that, not just the radio, but my whole setup here. I have to be very, what's the word? Can't assume anything here, that there could be problems anywhere in the way I've got this set up. But we should be able to get something like 2.5 volts for something like 0.5 microvolts on the antenna. So this can be calibrated. I don't normally use this in a calibrated mode because most of my tests, there's no need for calibration. A lot of them are just comparative tests. So let's just verify the calibration. So to calibrate it, I must switch this to here. I make an observation of what the frequency is. We're going to want this to run up in this band. 300 to 50 megacycles, good. This supplies now a calibrated signal to this selector down here. We check the calibration by flipping this knob to CW, making sure this meter is reading 10 with this control at max, and this is the one we adjust to get 10, a reading of 10. This means now that this control can be direct read when this switch is in this setting, but we can't read the frequency. But that won't matter. Once I have this set, we don't need to read the frequency. So we can flip it into a calibrated mode, and I know for sure, this is pretty high now, let's turn this down. So that would be X times 10. Times 10, not X times 10. If it's times 10, it's 1 microvolt times 10. I think. You know it says 10 here. I could be out by a factor of 10 by that comment. Well, I'd have to read the manual to be sure. I don't think there's any particular hint there. We're just checking sensitivity here. Yesterday I had tried my best to pick up some skip on the radio. By the time I got this thing going and receiving, I don't think there was any skip to pick up. So we just heard a hiss, heard the signal generator, but that was totally uncalibrated. So this time we're going to try a calibrated test on here. I think we're ready to go. So we're going to turn the volume down here. I think everything is set. I guess we should plug it in. Sure. There we go. It certainly takes a big charge at first. It's just withered down to nothing here. Give it a moment. Some more. Once the tubes start conducting, it'll draw more. There we are. It's brightening up again. Okay, let's give it the full shot here. Watching this meter misbehaving over here. That sounds like a squelch. Yep. I may have to switch meters again. Oh, that was nothing. Got one of those little nerve snaps in my wrist there, you know, that feel a little bit like a shock. And anytime that happens when I'm in here, man, I think I'm getting electrocuted. I think this lead is good. I got a lot of really crummy leads that I thought I fixed them all up. The answer, maybe I didn't. Something more going on here. Okay, so you know, I can't afford to have this, so we're gonna switch meters here. Son of a gun! Wish I'd done that right at the start. Make some space. Okay, coming down. Take a second here. I think we're in business now. Put it on the 10 scale. Okay, so hot lead on the green speaker wire. Other one on the ground. What's going on? Okay, I want to be absolutely sure these things are working right. I mean, there can be some variation in the volume doing that. Or it could be a little bit of a wonky lead, or who knows. So I think that's okay. So we'll flip it over to the signal generator. Now, we want to tune the signal generator so the radio picks it up. And we'll put this here. We can read the number. Well, I didn't hear anything. We'll up on the power. Hear the thumping? Oh, there's no modulation at the moment. Okay, hold on. So we'll flip modulation on. 400, we'll put it on 1000. There, you can hear it now. You can hear it coming out of the speaker. It's supposed to be done at 400, but we're going to do it at 1000 because it's just a little easier to hear. Excellent. Okay, so we're ready now to make a real reading. Fortunately, I think in the course of doing this, my ears might get blasted off. I'm supposed to have the volume up full to do this test. So let's just review. We're looking for somewhere around 2.5 volts on here. Wow, this is the 0.1 volt scale right now. One volt. Okay, so it's easy to get to 1 volt, but we got too much power coming in here. So we'll reduce this. And we'll make sure that we're tuned in. Reduce. Reduce. I can't reduce it. Okay, so a little blast there at the end. Looked to me like it was heading for 2. 2. Everybody, cover your ears. Okay. Easily over 2. Why can't I reduce this any further? Oh, this is in the wrong place. Take it all back. We're now sending, I believe, 1 microvolt to this receiver through these cables and whatnot. Can we make it to 2 on here? We can, but that sounded more like the rushing hiss doing that than. So I may not have it tuned exactly right. This is a little tricky to get this exactly tuned. Let's try it. See if I can just get this up on the scale here. No, that's it. $27,127. It's probably $27,120, $130, or $27,125 is probably where we actually are. So, result of this test is the sensitivity of the radio certainly seems to be thumbs up. Thumbs up on that. So the next test I want to try is transmitting to this radio again, as I did yesterday, only using a different walkie-talkie. In fact, did I show you the one I have on the wall here? I think I may have. So, okay, so here's a walkie-talkie sitting right here. Antenna's in the room next. This one's tuned to channel 28. I think that's a channel commonly used for skip. So this is basically the skip monitor waiting for skip to show up. But can't forget it's in the room. Now they've got to figure out what channel this guy's on. So what was it again? 127? 127. Let me just bring up a chart here quickly. Okay, threw away the chart I had. Just type in CB channel frequency chart. And here we are. Okay, so we're at 127, so channel 14. Excellent, of course, 14. That's perfect. That's exactly where I want to be. That's the walkie-talkie channel. So the radio on the wall here, the CB is tuned to 28, so probably it won't react if I go down yonder, turn on the other CB radio, and try talking back here on the CB antenna. We'll just squelch it out a little bit. And I'm literally going to run to the other side of my house. And transmit to this thing. So you're in charge while I'm in the other room. You're in charge. This is Jim talking from the other end of his house. Okay, so of course I don't know how that went. I have to stop the video and take a listen and see if anything came out of it. So I'm going to do that. Okay, so I took a listen to that. It's not as clear as it could be, but then I am using a lousy walkie-talkie, and the big hum that came through is almost certainly coming from the power supply of the walkie-talkie, which is something I have simply jury-rigged together. So I don't think the power supply has enough oomph. When I click the transmitter in there, I think it's too much for my little power supply. So, but nevertheless, I think that what this is proving about this radio is it's working really good. Really good, actually. I'm kind of stunned, in fact. So, really. So I'm going to study up on the alignment procedures for the radio, the receiver part, and we'll see about doing a little bit of it, check the IF frequency and do stuff like that. But really, wow, this guy is working. I'm floored. I really am floored so far. Okay, so I think I'm ready to try the next simple step, which is just measuring the ABC voltage, which is on this meter here. You can see the meter connections, the green clip going in onto pin 2, I think it is, of the IF transformer number 2. Out it comes just to the voltmeter lead here for this meter. So that is the ABC voltage. We're on the 5 volt scale, so that's a little over 2 volts showing there right now. And this is what's on there. Just a couple of interesting things I've noticed here. Whoops, I'm not sure what to make of them. One is we switch to the antenna. Oh, you got to be able to see that meter over there. So if we switch to the antenna, a little more ABC, a lot more hiss. Right now we can't even hear the modulation tone. It should be, oh, it's because it's not turned on. Okay, there we are. That's all a little better. Just turn this down a bit. So now the issue is, am I sending in a known signal level? Can I make a measurement of the ABC against this known signal level and look on the chart that's provided in the manual and see if it's correct or in the range of what it should be. So we'll start with, is there really a microvolt coming out of there? Again, I got to get the manual out and read this again because Well, let's so I'm going to go with this control means times this level here. So right now this meter is indicating modulation, it's not indicating signal strength. You can't even see the meter I'm talking about right there. But I calibrated it earlier, but let's be absolutely sure of that. Okay, so if it's calibrated, the meter will go all the way up to the top and stop at 10, which it does. So we have a calibrated output. So again, I believe this is 1 times the 10 that was on here. So I think this is 10 microvolts. 10 microvolts into the radio. Antenna, signal generator. Raise it up a little bit here. 10's not the right, well actually the chart will tell me what the ABC should be for 10. Let me look, quickly look. So if we have 10 microvolts, the ABC should be minus 3.9. Minus 3.9, so let's take a look and see what we got here. 5 volt scale, we're around 2. 3.9 would be up. Let's try that again. Okay, so we're around 2 volts of ABC voltage. Now if that was 1 microvolt, what we would expect to see is basically about 1 volt. Okay. So on the question of is the ABC voltage correct, does it meet the standards set out in the manual, I'm not 100% sure. Now on a slightly lighter test. Do I think this is working pretty good? Yeah, I think I think it is. And there's issues about the output of my signal generator. But for sure, there's an ABC variation when I vary the input signal strength. Let me do that. And how high can it go? Hey, there's a good question. How high can we push the ABC? The ABC should go all the way to, my gosh, minus 33 volts with a whopper input. Okay, minus 33. We don't need to listen to this. Can we get this thing up to 33? Okay, so on the 50 volt scale, 33 is going to be about here. And I'm just going to start advancing the input signal upwards. And we'll see where we get to here. We're up by a factor of 10. Another factor of 10. Okay, this is a pretty hefty signal. Another factor of 10. Well, let's see. So if this is 10 microvolts, I'm about to multiply it by 10. Well, 10 microvolts times 1,000 is 10 millivolts. 10 millivolts by another 10, I'm about to go, is 100 millivolts. What does the chart say about this? 100. It's exactly what it's looking for. Okay, so we're going to put 100 millivolts onto the back of this radio and see if we get 33 on the meter. Here we go. Hit them. Wacko. So yeah, 50. So we're looking at about 25 on this meter, and the meter itself isn't terribly precise. It's not bad, but so a little low. A little low, but I stand by my earlier sort of subjective assessment. I think it's working just fine. Excellent, excellent. I can't believe this. This radio's fantastic. Okay. Now I'm done. Next thing we will on the next video I will go over the first alignment stuff. I guess maybe the IF comes next. I'm not even sure. We will see. Thanks again for watching, and see you in the next video.